So they're asking us to find the derivative of sine inverse of x power 3 plus c x and plus 5 to the power x. To do this, we need to have some idea on how to differentiate inverse functions and also on how to differentiate exponential functions. For inverse functions, we have different sets of which they carry different forms. For example, you can be asked to find the derivative of sine inverse of u with respect to u. So u can be anything, can be any expression. You can carry this form like x power 3 plus x, or they can put anything. It can be an angle, just like that. Okay, so for you to differentiate this inverse function, you say you differentiate the u, which is the inside function. You get u prime over the square root of 1 minus u squared. So this is the form of which sine inverse is going to carry. Regardless of what u is, you just differentiate it, then over the square root of 1 minus u squared. Then you can also be asked to find the derivative of cos inverse of u. Here, with respect to u also, you are going to get negative, don't forget this negative, the derivative of u, which is u prime, over the square root of 1 minus u squared. So sine inverse and cos inverse carry the same form. The only difference is a negative that is put in front here. Apart from cos and the sine inverse, we can be asked to differentiate the tan inverse of u. So when you differentiate this with respect to u, you are going to get u prime, which is the derivative of u, over 1 plus u squared. So this is the form of which tan is going to carry. Then when you differentiate cot inverse of u, it's going to carry the same form. The only difference again here is a negative. So you differentiate u, you get u prime, don't forget the negative, over 1 plus u squared. Okay, so those are the basic inverse trigonometric function. The other part that can be asked is to differentiate sec inverse of u. With respect to u, you differentiate this, is same, you differentiate the function, which is u. This will give you u prime, then everything over here, some changes where we are going to multiply this absolute value of u multiplied by the square root of 1 minus u squared. Okay, mistake there, so it's supposed to be u squared minus 1. So whenever you're differentiating these inverse functions, you need to take note of what kind of a form do they carry. For sine, it's u prime over root of 1 minus u squared. Then for tan, it's u prime over 1 plus u squared. Then for sec, it's u prime over absolute value of u multiplied by the square root of u squared minus 1. Meaning that for the differentiation of cosec inverse of u, it's going to carry the same format as sec. The only difference is a sign again. So here we are going to have negative u prime over absolute value of u multiplied by u. So just use to x. So we are going to say u squared minus 1. So just like I said, u can be anything, can be any expression. You just have to find their derivative and also know the form of which they are going to carry. So since we have some basic ideas on what we are doing here, we can find the solution to our question now. So our question is asking us to find the derivative of x. So to do that, we are going to use the same format. We are saying y prime is equals to, it's the derivative of the inside function, which is x power 3 plus c x. So derivative of x power 3 plus x here with respect to x is going to give us 3. When you multiply this 3 multiplied by the 1 here, you get 3. Then x, you subtract a 1 here, you get squared, plus the derivative of x, it's giving us a 1. So this derivative is going to be our numerator. So say 3x power 2 plus 1. Then everything over the square root of 1 minus, since it's supposed to be 1 minus u squared, and our u we know it's x power 3 plus x, we're going to put the way it is. So it will be x power 3 plus x, then everything squared. This is the part for the differentiation of arc sign. Then we are going to add the differentiation of the exponential function. So whenever you want to differentiate exponential function of a base that is not e, you use this formula. Let's say we have a generalized formula, which is a base a to the power u, and you're asked to say what is the derivative of this one, where a is any number, then u it's also any function. To differentiate this one, to find its y prime, you say the derivative of u, which is u prime, multiplied by the whole function the way it is. So we multiply this by a to the power u, then multiply it by the natural log of the base, which is a in this case. So multiplying this by the natural log of the base, which is a. So this applies to most of the exponential functions that have the base other than e. The one that has a base, which is e, doesn't contain this part. The reason being, natural log of e is equals to 1, so no need of showing it. So coming back to our question, we have 5x here. So how do we do that? For 5x, we are going to differentiate the power, just like we said. Our power here it's x, so derivative of x is 1. Then we multiply this by the whole function the way it is, which is 5 power x. Then multiply this by natural log of the base. So natural log, our base in this case is 5. So this whole part is the differentiation of 5 to the power x. So relating our equation, we're going to have y prime, which is equals to 3x squared plus 1, then everything over square root of 1 minus x power 3 plus x squared. Then plus, when you multiply through, we're going to get 5 to the power x natural log of 5 as our final answer.